branch ID. I don't know whether this is the correct spelling. I'm pretty sure it's not, but I didn't find a way how to declare a relation about two tables.
You want to declare the relation. As I told you last time, you don't declare relations via code, or like writing commands. You don't declare it here. You just start building the ARD,
Mm-hmm.
and you add the same foreign key in the other tables, and this is how you connect them, like in physical way also. And if you use like one of like Oracle, or Microsoft SQL Server, or this kind of DBMS tools, they give you the possibility to that wizard. Like you can add this connection by
Okay.
wizard. I send you a link now, how to connect this.
Okay.
But in MariaDB, I didn't work with MariaDB as I remember, but I'm not sure if they have something like this, like to do that physically.
Uh-huh. Okay. So I have to try it perhaps in MySQL or in SQL, MS SQL.
Yeah, yeah.
Because I read that since version 10.5 in MariaDB, you have to declare a constraint to import foreign keys.
So did you add in your code foreign key? As I told you,
Mm, yeah.
this is usually you need to look like this. So do something like this. If you see Stack Overflow link, you did it foreign key branch ID. Yes, you did this foreign
Ah,
case.
sorry.
Yeah, I see.
And
Foreign
another
key.
one is
Yeah,
missing.
branch ID. This
This
is
is,
the foreign key
yeah.
department. Okay. Do you have in MariaDB also the possibility to to work with wizard, so you can create with double click and so on?
Yes, yes, yes. I have to look it up whether Heidi SQL will do this. I tried to do it via CLI this
Yeah,
time.
I see.
Yeah, but I'll try again in Heidi SQL.
Mhm.
I I have to think about again. The time was too low for me
Yeah,
to
it's
have this.
from Friday to now. Yes, I
Uh,
can imagine. Yeah.
yeah,
Okay, but what was the problem? You said you couldn't solve. What is the issue?
yes, especially here, this branch ID in employee
Yeah.
does reference about the department table and then from there to the branch table and then to the branch ID in the branch table. So it's not only like this. If I take this away for a short one, this would not be correct, I think, because when you look at the
Result.
no, if you look at this, just a second. I have to open this one. Okay, now. So this is out of the last unit, or unit 3. Huh?
Yeah, yeah. From it.
If you look here, it goes over the department and then to branch and then back to branch ID. There are two tables and here is only one. Huh?
Mhm.
And I don't know how to realize this in my SQL statement, in my commands, because I think this is not correct. in this case, branch ID so should be in branch, or would it work like this?
Let me check. Let me check. You wanted to make this reference, the reference. I can see from the second screen on the left side.
I shared. Okay. No, the screen is too small, I think.
Yeah, yeah.
Let's try it like this. Now you should see all, I hope.
Yeah, now I can see. Now I can see.
Okay. Is there somewhere a sample solution to compare?
To compare between what?
A sample solution to compare with my solution, whether it's right or not?
Okay, okay. I can send you that later. I can send you that later, but please write me in chat, so I can just send you that later, the right solution.
Okay. So
And
I
the
may
Torlak,
stop sharing.
yeah, you can stop sharing. Torlak, like, do you have a problem with any one of these about deciding the reference table, reference employee? Like which one should be reference? This is also your problem.
The thing is, so I I couldn't download the SQL. I write by hand those,
Yeah.
and I don't know if I do correctly. You can check, but I have problem about the references. Like, how should I decide about the cascade or not? No, these ones I don't understand these relationships. There was a name of this in the book, but I forgot to. I will find it. Yeah, like what is cascade, when I should use it, and the other things. There is
you,
the other
you need
choices as
you
well.
need yeah, you need to define that or understand that from your design. As I said last time, you transfer that from design, like if it's cascade, if it's not null, if it's null, if it's these things you have to decide based on your design. Regarding references also, I can't tell you like one rule. The rule is you need to follow the design, which one should be reference and which one should be belonging or connecting to that table or this table. So
It,
this
it
is
depends on the requirements. I think you are
yes,
telling me,
based on
right?
the requirements,
But
you make the design as you see in the task. It's based on the design. You start with the design, and then based on the design you transfer this to physical, and from physical you start to create these relationships and give the attributes.
is that okay? Well, like I separated, like for my side of normalization is like I separated branch table, employee table, and what was the other one? And department table. Is that okay?
Yeah, that's okay.
Huh,
From separation perspective, I find it's okay, because this is
okay.
like if you saw the like there was like in the page number 35, there was like how to think about it. So it was, first of all, you need to have employee, department, and the branch, and all of them should be separated.
Okay.
This is
And the thing is, I understand what you mean. It depends on the requirements how to decide about these references like cascade or not null or something. But I don't understand the meaning of them. Like when I understand the meaning, according to requirement, I can decide about it. But like when should I use the cascade? When should I use the not null? Like the meaning.
okay. Okay, the meaning. Okay,
Meaning.
not null. It means it's not possible that like this item, this item in this table, it's not possible to be null. Like what? Okay, I can share with you my screen. It's also containing the solution. Just a second.
Yes, that's perfect. Thank you.
Okay. Just a second. Screen. Can you see now somehow my screen?
Not yet.
No.
No. Ah, now it's coming up, I
Okay.
think.
Do you see the solutions
Now,
now?
yeah, yes, yeah, okay.
Okay.
Yes.
Yes.
So I will start to explain this not null. Okay, this is integer. It's a clear, right? Integer. It's a clear for you.
Yeah.
But not null, it means it's not possible inside this branch, this branch that you have a branch ID table. Null. It means not null. It means it should contain value. You can't when you enter the data, or when you give the application to someone. Sometimes when you enter data in application and when you leave some values empty, the application doesn't run, right? It doesn't accept that you leave like entry empty, right? Sometimes you meet applications like this, right? That
Okay.
means when you this that means it's this item is not null. It means you can't leave this item without value. You should enter integer, and integer value, and you can't keep this one empty. Is it clear now for you?
Yes.
Not null, it means it can't be empty. Null, it means you can leave it empty. So if you just remove this, like here. So if you don't add a branch straight address, and you leave it empty when you enter the data in database, this is later when you start to fill out your database, when you start to enter data entries, like when
I
you
thought it's
enter
like it could be zero or something, right?
this null. It means you can leave it. You can leave it without writing even. You can just keep it
Mm.
as it is, like
Okay.
empty. But not null, it means it can't be empty when you enter data.
Mhm.
It must contain value.
Okay. I was thinking that it could be zero or not.
No,
Is-
no, a zero is not null. No?
Zero,
Mm.
zero is value. Zero in integer
Ah.
is value. Like if I tell you how many items do you have, your answer is like you say, okay, we don't have any items from this product, so the answer is zero, right?
Uh-huh. Okay.
So zero is not null. Zero, it doesn't mean it's zero doesn't mean it's empty.
But my question was about that was not my question, but I learned right now the correct one. Thank you. But my question was about the references. When we are entering the reference, we are choosing cascade, set null, restrict, no action, set default. What are the meaning of this?
Okay, so let's okay. I will explain this, but
Thank you.
okay.
Okay.
So I mean, I just want to from you, like, please double check your solution first with the first one, and then we go
Okay.
to.
Okay.
Do you, do you see my screen still?
Yes.
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 Okay,
That's great. If,
okay.
if
Please check first one, and then we
mm,
go to the second one.
yeah.
Second one, or is still Tarlak? Is it
I
okay?
have a question. When you write branch street address, but then you write the country, city, postcode, or should it be branch street address ID? Would it be better?
Brand. Which one? Which one?
At the create table, if not exist bank employee under the branch ID, you write branch street address. Okay, street name is the
Street
street.
street street name. This one.
Okay.
No.
I thought it's like complete address.
No, no, no.
Okay. Street name, city, country, postcode, all is separate. Okay. I was thinking about to do like that, but then I thought it should be in the one varchar maybe.
Okay, so next one.
Department.
Next one, it's table bank employee.
Yes.
Yeah. So create table if not exist. Do you know why we need to this? Do you know why?
If it exists and we say create table, then he gets an error.
Exactly.
That's what happened to me.
Yeah,
You
if
write
you
branch
create,
ID there too. Foreign names has to be in the inside of the table again.
yeah,
Okay, I should have written that too. And you have two primary key.
it's in this case it is
Two primary key, branch ID and department ID. Why? And you have also branch ID as a foreign key.
yes.
Could it be?
Yeah. Here you have like you have foreign key. It's possible to have foreign key from many foreign keys. What is the problem here?
But for the same table, we could have primary key and the foreign key the same, because you have branch ID as a primary key and you have branch ID as a foreign key, and also constraint. For example, I don't understand this constraint as well.
Here you have you have the foreign key. This is branch ID.
Uh-huh.
This is your foreign key, and you have here constraint department branch. Also, this is coming from another one, from another table. And you have your is the department ID. Here is the primary key with branch ID. Do you see this? Do you see this or no?
Yes,
Yeah.
I see.
Okay, so
So branch dependent to department, employee dependent to department, and
yeah,
department dependent to branch. Okay.
I mean you need really to draw this like so you can understand or like to have the feeling. Okay, for you brand, do you have here references, right? It's the same for you.
No.
Yeah, that's the version with constraint. I will try this in MariaDB. This is the new formulation. I'll check this. Okay. Yeah, it's
Yeah.
a good idea. Yeah.
What is the function of constraint?
You mean this one?
Yes.
Constraint, it means it has the same meaning. You can't do without constraint. Like in this case, constraint means it's a must. It's based on this department branch. So it means connection or like you connect the department. If you see this department and you connect how this one connected with branch, how they are connected.
One to many.
No, I'm not talking about how one to many now. I'm thinking about which value here, which attribute here is connecting to branch.
Branch ID.
Branch ID. Branch, look, branch ID, this one. And it's connected with branch ID. This is so this primary key here, it's foreign key here. So here constraint means the foreign key of from department branch, which is this one, is the one who making the connection between the other table.
But
Like
also
you
still,
just try here to clarify which one from the other table is making connection with this table. Is it clear for you, Brand?
Mhm.
Like how do you write it in MariaDB? I mean, to make this.
Yes, I would write it like this in MariaDB with constraint.
Yeah, but you said it's with the version you use, it doesn't work, right?
Yes, it works up 10.5 and higher.
Okay, okay,
Yeah, yeah. So
I see.
I'll try this again in the newest version, and then it should run.
Yeah, yeah, I see.
Mm.
Okay, what else? Like, let's go for the third one.
but
Can you,
could you say that the references for this bank employee
this one?
is that cascade, set node, restrict, no action, or set default? What is that?
I mean, you mean this line or where?
Yes, for the references, what did you choose?
Like here,
Hmm.
it's just left as a default.
Default. Okay. Why?
Yeah. I mean, I mean, usually, if you don't need to have some restriction, why do we use or add this cascade word?
I don't
Because
know.
later, I'm explaining now. Later, when
Oh,
you create the database, and when you delete the whole data from employee, so you have connection between this data and other tables. Like in this employee was working in that department, and this employee had like some branches. And if you use this word cascade, when you like delete or update and so on, the change will impact on all other tables who related to that employee. Like, if you say, okay, this employee ID, and this employee ID is foreign key in another table. If you delete the data you entered for this employee in that table, and you need to insert values for this employee, if it's cascade, it's a must to add all the data when you insert related to this employee. So it should impact on all the rules related to that employee. This is for data consistency. Like, if you delete one row from the table, and this row is connected to another table, like if you delete one employee from here. Do you see the mouse here?
yes.
Okay, so if you delete employee here, and this employee had branch and has like department, is so the question is here in cascade. As I told you, it's based on your design. It's not something like it will be always cascade or not always cascade. It's based on your design. Okay, if I delete department ID, and I have employee with this department, if I delete this department ID, it means it must be cascade, because any department I delete, and there was an employee in that department, I should remove this, and it will be null. So I make this department for that employee null, right?
Mhm.
So, like, are you with me?
Yes.
So the idea, if you create the data, and this data, or this column is impacting on the connection the connection or the relation that I have with this table, it means I have to do cascade. Do you understand what I mean now? Like
So
cascade.
accepting the your adaptions when you do cascade.
Yes, yes. As I told you, it's only based on one thing,
Mm.
your design. That's why if I can tell you, I send you also one link about this. You can also have a look about that cascade in SQL and what does it mean, and some examples, a lot of examples there. Please go through them in details. You will understand that better with some examples. Please try to use these different examples, and it will show you. And later on, also when you delete the data, it's very important also to understand if you delete with cascade or without cascade. What is the impact if you want to update, if you want to insert.
It's automatically changing then.
Exactly.
Mm.
This is the point. So if you want to like do your consistency with data based on like something, you have to define that from the really beginning. That's why
Mm.
I told you start with drawing and see what is like. If you see from this one, okay, if I delete employee,
Mm.
I delete employee, it doesn't make any sense, like any cascading and change on the department.
Mm. And if it is restrict, it doesn't give acceptance to this deletion and
Yeah,
no
yeah.
changes. Uh, okay. And this should be, I think, it should be very clear in the requirements, right? Then we can develop this.
In the mess as a example I sent you, you have like table 3 and the table
Mm.
2. How it's implemented with both, please just go through these examples, and it will give you like a better understanding, and it's also giving you a better like more examples about references and how to define them and so on. I think it would be also useful for you, brand, as well.
Yes, yes, I will.
Okay, for the table employee, it's also creating the table, employee ID not null, department ID not null, because it's coming from another one anyway, from another table, so it's not, it can't be null. It's branch. I mean, there is a connection between the department ID and the employee. Branch ID as well, not null. Employee first name, last name, it could be null. This is also based on your design. Some companies doesn't accept that first name is null. It's based on you, based on the design you have.
Yeah.
Some companies use this first name and the last name to like to create ID, and so for the employee, or to create email. So it's based on your design. And the primary key in this table, it's employee ID. Constraint for foreign key employee department. Foreign key, here is we have department ID which coming from the department, and the branch ID which coming from branch table. References you have here. Do you have the same brand, or it's a different, because I don't
Yeah,
recall.
yeah, yeah. That's the point where I was unsure how to declare this reference, but now it's clear. So I'll try
Okay,
again.
great. Okay, so please also go through this page I sent to you. It makes really sense.
Yeah,
Why
yeah,
did you add branch ID and department ID to the? Because it is the third one. It is connected to only the
it's
department. It
connected.
is
It's
not
like there is a relation. There is a
connected
relation with the
to.
other table. So you just say,
Hmm.
okay, it's a reference. It's a reference to another one.
But if
Like
it is
like
connected to.
you know when you make like link connection in HTML and CSS, If
Mm.
I'm not sure if you're aware of HTML, how to make links in HTML.
No,
Do you write HTML?
no,
Ah,
not yet.
okay. So it's not a good example then. Like it's just a reference. It's just a reference saying, okay, this is the reference to the other table. Is it so? Please, Turlak, go to the page I sent you and also read the examples there. And if there is something not clear, we can go through together next time. Okay?
Okay.
Can 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 we say that a primary key should never be null? That would not make sense.
Primary key, it must not be null. Yes, it must
Yeah,
not be null.
must
Yeah,
not be null. Yes, the primary key must not be null. Okay, so it's a good
but
idea if you define the primary key that you write not null.
yeah. I mean, this if you work with wizard, it will you will feel that better. If you work with wizard,
Mhm.
how to add tables in wizard and how you select these options and sees that change when you enter data, how that impact on your data entry. You will have a better feeling for that.
Okay.
So I advise you to create tables, to start to create tables uh, in wizard, like try to do that in
Mhm.
wizard, to select and create and do everything, and try also to create to add data, to enter data, and
Yeah.
to delete some rows and select some rows with select statements and so on, and
Mhm.
see the impact of that. It will help you to better understanding, because
Yeah.
uh, these things really coming with practice. When you do, when you create table, when you have a connection between tables, when you delete one row, these things will be easy and feasible for you a little bit better.
Yeah. Yeah. That's true.
So for today, we are going through today. It's a very quick one. It's because it's joins only. We are explaining the complex database queries on multiple tables. So it means is the joins between the tables and how you use SQL statements to present data and so on. So the study goal of today. I hope you still see my screen.
Not right now. No.
Yes.
No.
What? It's every time like this. Okay.
It's a
I
little bit delayed, maybe.
I have to share again because it stopped. Uh, okay. So can you see something now?
Not at the moment. Ah, now it's coming up. Yes, now it's here.
Okay, great.
Study
So
goes. Yeah.
use study goals. Use composite quantities or joins to query more than one table. Use set operations to gather combine the result of more than one query. It's very important. Use views to reuse the result of complex queries. Okay, so today, what is the main advantage of joins? Joins is a way we use to reduce data redundancy, as well as it allows different tables to be related to each other to create meaningful information. So joins is like we use joins to just collect data from different tables without redundancy, without repetitions, just without redundancy. Why are these different types of join? Why are there different types of joins between tables when we get data? Why we have different we have different types of joins? We will go through them today because Why we have different types of joins? Because in some relations, there are some keys in one table match null values, and in the other side there are also some entries are null. So in that case, it doesn't make sense to like bring like data with null. So I just want to present or show the data without null. So for that, we have different joins type join types which we could use to just to figure out which data we need. Okay, does any one of you heard about does any of you heard about view before?
No,
View.
no, I haven't
Okay,
used
this is very
Vue
important.
No.
up
View is
to
very
now.
important. It's a very important concept in databases. It's virtual table. So you have physical table and you can take view from it. Not the real one, but view from it. It's like mirror. It's like mirror. So you view is a virtual table. It's usually created using SQL query to be reused in other queries without the need to repeat the entire code of the query. Like if you get like some results from your queries, you can say like you can use these results again and again without the need to repeat the entire statement that you write or the code that you write. So it's a way to m- make it easier for you in the future when you write like statement. You can make from it like view, and then in the future you can this the view or this results that you have as a new table. This results will be like as a new table. Okay, it's
Mhm.
like another table with the results, and then you can use them this new table to run new query on this one.
And the view is static. So if the source changes, the view does not change,
Yeah,
or does it change?
it's the view it's itself now has a result. Okay, and it
Okay.
has a name, and now you are working on this name, right, with the new
Yeah.
like with this new one. If you wanted to like listen to change, if you wanted to listen to change, you need to go back to the table and listen to the changes again.
Okay.
Okay, so it's like virtual table. It's a virtual
Mhm.
table new created using an SQL query.
How can you do this in the like SQL? Like, is there a
You, I
tool?
mean we will go through that step. I
Okay.
mean now it's just like start to get to action. We will just start now with like some definitions and some meanings and so on. Okay, so advanced query.
Advanced queries on several tables. One of the most essential characteristics of relational databases is that they tend to eliminate data redundancy and all anomalies caused by it. We can see in this table that data about local offices and main branches is redundant. The same data is repeated in several rows. In order to eliminate the anomalies caused by data redundancy, the table is broken into more than one table, and the relationships among the tables are created by inserting the primary keys of parent tables into children tables. Often, we will need data that is distributed over several tables. For example, if we want to know the main branch responsible for the client C1, we need to find R1 in the rep table, which will lead us to the local office ID, leading us to the main branch MP1 that we can find in the local office table. In SQL, some queries allow us to create this kind of query, but using join is less complex and more efficient. In this unit, we will also look at the set operations, union, union all, intersect, and minus. We will also see the views that are used to simplify the creation of complex queries.
Torlak, did you see how it's written? The view?
No.
It was in the video. It's in the video. I mean, it's already recorded. So when you watch, also you can see how it's written.
The
Okay.
thing is, like, where is the tool when you apply? For example, when you create this one, like, where is the tool that we can see the view or we can apply to the view?
Like it's written create as you create table. It's create view.
Hmm.
And this view is just reflection from tables. Like what's there, you just take image from that one.
Okay.
So the idea from view also, if you like working in a company and many of like employees working in the main table, so you don't need to like to think about the changing happening anyway. If like if there are changes in the table, it will impact, but now you can update and delete on the view, and in the future you can send these changes to the table from your side, but you don't impact on the table now. You don't impact on the table in the view, because the view it's just this mirror of the of one table.
In the book, it says the view does not contain an aggregate function, constant, or expression. What that mean?
Again.
I can attach what is written
Yeah,
here.
you can put it in chat. Yes, you can put it in
One
chat.
second, so you can maybe explain because it's
But you see my screen still, right?
no
Oh, so
here. The view.
you can see my screen at all, right now?
Not no.
Okay, because I just clicked the exit. Okay, the view doesn't contain any aggregate function. This is the ones we studied last time.
Mhm.
Aggregate functions, constant or expression. The view only refers to one table, or so no join is allowed. This is like it means like this aggregation functions and this constant and this expressions are implemented for tables, but view is just, as I told you, it's like virtual table. It's not something impacting on the database. It's like virtual from one table.
Hmm.
It's
That's
kind
why
of a snapshot.
we don't exactly. It's could you like the snapshot you have, does it impact on you in like on your screen, or it's just is it just a one snapshot?
Hmm.
It's just a snapshot. Do you know what snapshot is?
Yeah.
Yeah, so it's exactly like snapshot. It's not the main table. To do this
Mhm.
kind of things, you need the main table.
Okay.
I hope you can see my screen now.
No.
Now it's coming up.
Yeah.
Now it's here. Yes.
Right. Just okay. So let's go through. Okay, so you have customer. Like you have customer, you have financial advisor, you have branch tables. So you have three tables, and you start to think how can I get like data from this table and this table, and this table was join was join was joined Like how can I do that? Okay, so you need to think about this now. Like how can I get the connection between these tables to show in the results like the customer ID and which which branch, which branch is like taking care of the financial advisor, and which financial advisor is taking care of that customer. So you need to like to start to think about it, how we can do this. So you have like so the if you need to show like this like result with branch ID, like branch ID and branch address and the branch phone number. This is easy because you just select everything from one table. But if you wanted to connect the data from two or three tables or even more, you need to write more complex statements. Like this one. If you wanted to like to present like financial advisor ID, financial advisor first name, last name, email address, and the branch ID, and like you start to get more data from different tables, and this one as well. So let's see how we write like how we write our joins. We will go through this a bit quick, and in the video I will show you in the video how what is the difference between different joins, like because we have inner join.
Before you start this, can I ask a question? Previous picture or
Which one?
later I can ask? One before with the tables with the relation.
This one,
Yeah,
yeah.
this one. For example, this between branch to financial advisor. This is with dash. That means I just want to understand it correctly. With financial advisor, it could be many financial advisor for a branch, or it could be no financial advisor at all, right?
Yes.
Okay.
It means like it could be or not, like it could be for some or not to be.
Okay.
Okay, so let's go through like if you wanted to like show something like this. So you have the different data as you watched it here in these tables, okay, containing some data, okay, like this data what we have, like 1, 2, 3, and we wanted to show from this like advisor first name, advisor last name, first name, last name, and the email address. This is like joins between three tables, from three tables. So you first of all you say select advisor, financial advisor dot first name. So you select first name, this one, last name, first name from customer, customer first name, customer last name, customer email address, from. After from, like this selection to write, it's easy. It's this till here, it's easy. You need to think about what you need to write from here, like from, because this is what you need. This is what you need to present. You need to present the financial advisor first name, financial advisor last name, customer first name, customer email address. From what? This is the idea now. Like you can't say from one table and that's it, because this not from one table. These values are not in the same table, right? So in this case, you start with like from customer, inner join. Inner join, it means is the intersection. In mathematical way, it means in intersection between customer, inner join financial advisor table on customer dot financial advisor ID equal financial advisor ID. On here means this is the condition. This is the condition. If and only if the financial advisor ID equal the financial advisor ID, like the foreign key, the foreign key in customer is equal to this is the primary key in financial advisor. In that case, it will select every column from this 1, 2, 3, 4, 5, based on what? The intersection between customer table, which has a connection with financial advisor, which satisfying this condition, this advisor ID and the financial advisor ID. If I will go back to show you, like you have, first of all, you have here, like this financial advisor name, first name, last name, and the email address. This is for financial. And try to keep this in your to keep this photo in your mind. And you have here, you need customer first name, customer last name, and the customer email address, where the financial advisor ID is the same financial advisor ID. Like it's, do you know how it's working? It's based on this. Checking the one, like alias, check alias, okay? Alias Wagner, and this is the email address. Which financial advisor was here? Go to financial advisor. This one. It's Lucas Muller. Lucas Muller was alias alias Wagner. Lucas Muller with alias Wagner. Do you understand what we need or the output from this?
Yes.
Okay, so the idea here, you connect the tables based on the financial advisor ID and financial advisor ID, which is in the customer foreign key. Which this, it would also give you a little bit more information.
Query more than one table using join. Joins are very efficient and flexible in querying tables and sometimes allow us to create queries that are not doable using subqueries. Here are sample tables from a database. These tables contain data about orders, representatives, local offices, and main branches. This diagram shows the relationships among the tables. If we want to find the main branch responsible for serving C1, we can join the three tables as shown here. Notice first that we are adding the table's names before the attributes to prevent confusion. The inner join returns the intersection of the records in the joined tables on the shared attribute. The join itself needs to specify how we are relating the tables. And this is what we add after the on in the query. Notice that we can have more than one join, or in other words, as much as we need of joining tables in one query. Some queries could include tens of joins. Notice also the where clause that restricts the results returned by our query to only C1. When we use left joins, the returned results will contain all the records from the left table, which is the table before the word join in the query, and only those records from the right table for which the relation attribute has a match in the left table. The same thing applies for the right join. In this case, the returned results will contain all the records from the right table, which is the table after the word join in the query, and only those records from the left table for which the relation attribute has a match in the right table.
Select. It's very important to understand this different type of SQL joins. I'm still explaining that, and also there is one video with animation to make it easier for you, because we have, as I said, inner join, left join, right join, and outer join. Now we need to select customer first name, customer last name, customer email address from customer. Like you get, if you work as a database developer, you can get task like say telling you please select customer first name, customer last name, customer email address from like connect a relation between customer and the financial advisor, where or when. Like I can give you like the condition I need. The condition coming usually here after on. Here on, this is the same one from last time. On financial advisor and financial advisor ID. Look where there's like I'm adding now more conditions. Where financial advisor, now I'm making more filtration. Where financial advisor first name like Finn, FINN, and financial advisor last name like Schmidt. So now I'm selecting the customer data where his or her financial advisor first name is Finn and last name Schmidt. Let's go back and check like which one. So financial advisor Finn Schmidt is number 3. So let's go to customer and see which one number 3. Like this one. Look, Patra Simpson. Do you see that? This is number 3 here.
Yeah.
So it's, yes, it's already the one. Like Finn Schmidt is taking care of Patra Simpson. So okay, so I wanted to clarify here, like we have SQL joins. This is if you studied something with, if you studied math or mathematics, you will understand that easy. Like the difference between these joins and so on. So you have inner join. So inner join, you need to select like the one having data in A and B, this intersection between on A.K بتساوي B.K. Like the data from A or the ID like or the foreign key in B with the primary key in A, or other way around. It doesn't matter because it's inner join. Then we have something called left join. Left join will get everything from the left side, and the related one from the right side. So the data from right side with null will not be shown. Okay, what about the right join? What about the right join? Right join will bring everything from the right table, with the related one from the left table, and the rest will be left. The rest will be left. Okay. So, okay. So if you select, look here, select fields from table A, left join table B, it should select all of this with the intersection. But if you say on A dot K equal B dot K, where if you do filtration, B dot K is null, where B dot key is null, it means it will remove the values which is null in B. So in that case, it will not bring any one from B which is null. What about this? If you select the fields from table A, right join, so it means right join table B on A dot K equal B dot K, where A dot K is null. It will bring the other way around. The like the other way around, not like the one on the left side. Like it will bring the data which we didn't get from the left one, the one on the left side. Okay, what about the outer join? The outer join, it's easy. It's like it gets unite. So it gets like all the data. It will get all the data from A and B. What about the outer join without without null value, where A dot K is null or B dot K is null? In that case, it will bring everything without intersection. I hope you can see.
Remember in the previous lesson, well, let's look at this animation again. So as you can see, we want to join these two tables, and then Patrick is going to be joined with climbing and code. And because there are two rows that are matched, you simply have two of the Patricks. All right. So now Maria gets paired with Star, Darwin gets paired with Apples. So what about Albert, Elizabeth, and Rugby? Well, these actually just get discarded. So this is actually an inner join, which is the same thing as join, because by default, join is an inner join. We'll talk about that more later. But what if you want to keep them, like Albert, Elizabeth, and Rugby, even if there are no matches? And one reason you would want to keep them is if you want to count how many things these users like. Like, for example, Patrick likes climbing and coding, so that's two things. Maria likes stars, that's one thing. And Darwin likes apples, which is also one thing. And then Albert, technically, they like 0 things. And Elizabeth also, she likes 0 things. And I want that on my table. But currently, I do not have that. I only have the people who likes at least one thing. So what if you want to have the users who like 0 things? All right, so you would have to use different kind of join, which is what we're going to be talking about today. So there are actually 4 types of joins. And we learned one of them. We learned inner join. Like I said before, this is the same thing as join, because by default, join is an inner join. But you can specify left join or right join or outer join. So for inner joins, when the rows are not matched, they are dropped, kind of like society and dating. So to learn these type of joins, we'll reference this website you can go to, which is really great for learning joins. It's called joins.spartan.com. So here they have a very good interactive visual UI where you can click different kinds of joins and you could see what the difference is. And then here you can see the 2 tables that they're joining, users and likes. And then in the middle, this is the resulting table of this query, which uses an inner join. As you can see, they only use the word join because by default it's an inner join. As you can see here also, or join, inner join or join. All right, so we'll use the same example, but let's visualize the Venn diagrams a little bit deeper. All right, so now we have two circles. Now think of the left circle as the leftmost table, which is a table that we're querying from, so the users, and then the right circle is the table that we're joining to, which is likes. So as you can see, it's the same diagram here, right? Okay, so let's look back at our example. So all the users, they are indeed users, so they belong here. So we got Darwin, Elizabeth, and then we got likes, like stars, climbing, code, rugby, and apple. Okay, so this is essentially the right table, and this is essentially the left table, and we are going to perform a join. So first of all, what is in the intersection? Well, in the intersection are rows that have the same ID. So for example, Patrick, like climbing and coding, right? So they belong here. Okay, we'll just put them like this. And then Albert stays here because it does not have an intersection with likes. Maria, on the other hand, likes stars. Perfect. So I'll put you here. And then who else? All right, Darwin likes apples. Great. So as you can see, Albert, Elizabeth are left out, and then rugby is also left out. Okay, let's go back to the website. So an easy way to interpret these Venn diagrams is by looking what's inside. For example, for inner join, they have filled the color in the middle right here. And then if we look back at our diagram, it means we want to contain all of this information, all of these rows. So you're going to get Patrick with climbing and code, Maria with stars, and Darwin with apples. And then if you look at the example, that's exactly what we get. We get Patrick with climbing and code, and then Maria with stars, and Darwin with apples. Awesome. Now what about left join? So if you click left join here, as you can see, the SQL changed. It's using left join instead of the normal join. And then what's the difference? As you can see, there is a difference. In inner join, you don't have Albert and Elizabeth. And if you look at the resulting table, if there's no match, we just assign it null, like Albert and Elizabeth. And then, as you can see, the diagram here is filled red, including the left-hand side of this circle. If you look at the diagram, that means we want to include Albert and we want to include Elizabeth now. And then it's just going to be nulls for them. They have been matched, so they have something that they like, but we have Albert and Elizabeth now. So that's essentially what the Venn diagram is talking about, because we want to include everything from the users table.
I hope, Turlak, now you can understand more what is null meaning. Null is like this, like empty data.
Yes, and this joins is like okay, I can ask later.
Yeah, you can ask later.
Match.
But I mean, this example or this animation is very good. You will understand the joins very good from this animation, and I advise you to use this joins.spason.com. This is a website. You can open it in your browser and check this. It will give you with this animation better understanding.
That's
right
really
key.
great.
All right, what about right join?
Sorry.
This site is really great.
Yes, it is. It is. I mean, see how you see things and how you feel the data.
The best explanation I've ever seen.
Yes, yes. I mean, it's really great. Great. I mean, how they present this, like, and the connection between the tables and how you get data and some data not and so on. It's very important how they do.
Right join is the same thing as left join, but instead of keeping the rows in the original table, it keeps the row on the join table. And in this case, it's the likes. So if there's no match, we just assign it null. As you can see, the only one, if we look back here, the only row in likes that has no match is rugby. So this time we will include rugby because we are including this whole circle, but we're not including this side of the left circle, which is Albert and Elizabeth. So as you can see in our example, there is no Albert nor Elizabeth. However, there is rugby, and then we assign null to it because it has no match from the user's side. All right, what about outer join now? Outer join keeps everything. It doesn't matter if there's no match. It just keeps everything. So as you can see, that's represented in the Venn diagram. It fills out both circles, so which is an outer join. All right. So as you can see, if you look at the table, every single user is here. Patrick is here, Albert is here, Maria is here, Darwin, Elizabeth. And if they don't have a match, they'll just assign it null. And then also the likes are also all there. As you can see, we have climbing, code, stars, apples, and rugby. And then because rugby doesn't have a match, it assigns it null. And if you look back at our diagram, that's exactly what we did. If we include everything here in this whole 2 circles, then we're going to just get every single row, right? And then Albert's going to get null, Elizabeth is going to get null in terms of likes, and then rugby is going to get null in terms of users. So how do we actually write these joins? So let me show you the query. It's quite simple. You can also look at the visual joins. As you can see, there's different here. You can use outer joins, or you can use this fancy way of doing it with union. But I have a feeling that you can just use outer joins depending on which SQL languages. That's why you should always Google it. Depending on your SQL flavor, it will be a little bit different. But okay, so let's go back to Photoshop. So yeah, so you can either do just inner join, which is the same thing as join, or if you want to do left join, you just replace it by left join, or right join, or outer join. Usually, I think it's called full outer join. At least on my company, it's called full outer join, but it can be anything. So yeah, so that's how you use the different kinds of joins. So let's do a refresher. So I have a clip for you, and we are going to go through the different kinds of joins again. So let's go back to the beginning. Okay, so this is inner join. As you can see, it's going to join every row that has a match together, and then it's going to leave the other ones out. Okay, and then we're going to have, this is the left join. As you can see, what we want to do is we want to include all of them. Patrick, Albert, Maria, Darwin, Elizabeth. It doesn't matter if there's a match or not. So that's why I'm just putting them all in the middle right away. And then we go ahead and match them. All right, got matched. And then everyone else, oh yeah, and also Patrick is 2 rows. And then everyone else gets assigned nulls. So that is a left join. Okay. Now let's do a right join. So same thing, but instead we're going to include all the likes this time instead of users. And then we go ahead and do the matching. All right. And then the last one just gets null because rugby does not have a match, so it's a null. That's pretty much it. And then lastly, outer join, we want to include everything. So we're just going to keep putting them there, right? So now we have all the users, we have all the likes. And then if you don't have a match, we'll just assign null to you. To be honest, most of the time I only use inner joins and left joins. Outer joins are not that useful in my opinion because there's not a lot of time where you want just like to include everything, because you either care about just the users or just the likes. Like you want to retain either one of them. You never want to retain both of them. It's not that useful. Last reminder, just for fun, let's think about these different joins. Inner join, which part do you color? Yes, that's correct. You just color the middle part. I am not very good at coloring. Okay, good enough. Left join, which parts do you color? Do you color this whole thing, this whole left circle? And then for the right join, which rows do you include? The middle one and also the right one. All right, and then outer join, the easy one, which rows do you include? All of them. So you just color the whole thing. That's it for the different kinds of joins. I hope you like this lesson, and we'll use these joins in the next lesson using mode, and you can see the power of it. All right, thank you so much, and I'll see you in the next one.
I hope it's a bit clear now for you. So joins is very important, while also concept. So please keep it in your mind.
So we are using, sorry, we are using these joins like when we test our, or when we try to find out the data that we are looking after.
To filter the data, the data based on the entries, like you have many entries, like you have thousands of entries,
Mm-hmm.
and your manager is just interested in like telling you, please bring like or show me only the employees
Mm-hmm.
who like to play soccer or who like to
Mm.
play volleyball. So in this
Yes.
case, you don't select all employees. You just select employees with the interest, this interest or that interest, like who play football or who like to play volleyball or whatever. So
Just for two tables, or we can do like more for more tables too.
as you watched in the video, he said it can be even 10 joints. Like
Oh, okay.
you can do that. You can do that with many tables, but it's getting more complex. But I advise you to just work now with two tables first,
Mm-hmm.
understand that very well, and then you can start with three and four, because this is
Okay.
very advanced level. This is
Yes.
high level.
Yes.
Okay.
Okay.
So let's set operations. Let's go for set operation. So anyway, we select column from table, and then like we have in union. It's exactly like we used join union all intersect minus. This is to remove some like amount of data from, like if you remove amount of data from the results you get some results, then you can also do minus to remove some data, intersect to do intersection between some like column or specific data. And you have select in this one to set, it's called this set operations. And here you have like something for filtration. So first we start with the select, and then the keyword of this set operation you can select like maybe union, it means all, and then you start to filter based on like where, and then you can use group by to group by the different selections you have. This is how we write it. We write select column from table one, and then you add the set operation you have, like in one of these, and what you wanted to do here, like you wanted to union with something, or you wanted to dot all to get everything, get everything which applying based on this filtration, or with intersect from this filtration, or minus to get everything from this table, to get from this column from this table, and then remove some data based on this filtration. So this is the set operations.
So one of these we are applying, right? Not all of this, you mean?
Yeah, only one. This is like it's saying select one of this. This is how it's working. Like here, this is example. Here I wanted to select customer first name, customer last name, customer phone number from customer. Okay, union with like with it means union select financial advisor name, advisor last name, advisor phone number from financial advisor. Do you know where they are? They are these. Like first here first we selected customer data with their phone number. Okay, those. And then union, it means you select first and then add at the end of the table the what's coming, like the coming here, what this, like I select first all the customer data, this are the customer data till here, and then from here it's continue with union, means plus the result from financial advisor table, and they are here. Like you can ask yourself, when something like this could be important. Okay, I like your manager can ask you, please, or for like like just print out all students and all professors in one table. So you can select first all students, and then you select all professors. So it means is how like how many do you have? You can just count them and say, okay, now we have like all of this. This is kind of like examples. Is there are many things you can think of, but this is like if you wanted to collect all of them, like, or union first selection and second selection. So the views, the views, as we said, or you're asking toilet how we write them. You, as I said in the beginning, or I just to give you an idea why we need this. We need view usually to limit access. Just imagine if I give access to everybody to manage my data on my table, it will be really mess. But view is like virtual table, and you have some contents inside. It's just taking like a picture or a snapshot from the table, and you can give like others access to that view, not your table. You can just give them access to view, not the table, if you want. It's based on your decision. Like, just imagine if you give access to to your customer to have access to your data, your table data directly. It will impact, like they can delete, they can update, they can. So it would be not good option for you. So now we create and use view word and give its name, like this is the name of the view, as. And in this as, what's inside, you select everything from article, inner join, film, using article ID, where availability equal immediately, order by name. The result of this, the result of this will be a view, will be like a view, or you can share this with like customers, then they can have access to this, they can play with this, you can give them access to delete, update. It doesn't matter because it's just a view. So uh, here is example of creation and using view. You create view with a name as select customer first name, customer last name, customer email address, from customer inner join financial advisor on financial advisor ID equal financial advisor ID, where last name like Finn, and the last name like Schmidt. If you remember this one, we did it already before. Select asterisk from customer, where customer last name like we talked about also this this one. This is the sub. So like the result from this one, select customer last name from view customers of in Schmidt. If you can see this, if you can see this, this one, this one is view, this one is view, this is not table, this is view. So you select the customer last name from the view containing what? The view, if you remember, was containing the view was containing the Patra Simpson. And this, in this case, you are selecting all from customer where customer last name equal what? Equal the result from view. So you get the customer last name from the view. I hope it's clear for you now. Like
Yeah.
what's happening here? It's on based on the view, not based on the table, because the view now is kind of result from table. So in the future, you instead, so just imagine if you want to, if you here, if you just wanted to get the value, this value, you had to write all of this. But because of your created view and you give it a name or a reference, this one, you can just put it here, and it's containing this values, which is which is first name and the last name, and
And
it
how
was
the
first
sorry.
name, last name, and email address. This is the three results we had. Okay, Tarlet, go ahead.
So when we create this view later, can we combine this with the previous table?
Yes, you can. You can combine them in like, but it will be like another table. You can combine them, but it will be like output. It's not real. It's not real table. Now like this one is not real table, right? This is just some results, right? Right? This is like results. Here you just show some results, but you can adjust that or add that as results here. You can choose this result, but this is nothing, and it doesn't have anything to do with the database now. Like, you can't add this to your database now, right? This is just results. Do you understand what I mean?
Yes, somehow.
Okay, I can explain to you. Like, what's your purpose? What's your purpose? You wanted to show like the result from the view plus the result from one table, right? That was your
Yes.
question, right? Okay, that's possible. That's possible. Like, you as we did here with union, like with this union. So to present this, you can do whatever you want. Okay, so review study goals. Use composite quantities or joins. Use set operations. Use views. That was the task from today. So transfer task. What is needed from you? You just need to go through this one, number 1 and 2 and 3 and 4. Transfer tasks and present them, and still tell 7 and present them next time. Okay, this is the time of questions. Left joins will return what? A, B, C, D. What do you think? I mean, anyone can answer. It's fine for me.
It's A.
It's A, exactly. And which of the following is the correct about the set operation in SQL? Do you know?
No.
If you remember, the number and the types of the columns of the different queries must be the same. Like what we did, like it was first name, last name, and the telephone number from the customers and the advisors. Which of the following is used to reuse the result of complex queries?
B.
Create view. Yes, this is one of the targets to use the result again in the future. That's it for today. Please try to finish this tasks in time, and see you on Friday. Bye bye.
Bye bye.
Bye bye.
Philbach? Hello?